This is the part of the movie where, you know, monster was chasing you, and now monster stopped chasing you. And now monster's going to come back. Yeah, go rawr. Is everyone ready for monster to come back? Alright, here comes monster. At least you know the monster is coming back. Oh, that's true. For the function given, find the intercepts and any asymptotes or holes necessary to sketch the graph. So this is the whole shebang. So this one question summarizes the entire section. Fantastic. Now hold on to your excitement. Let's talk about the domain first. I should have that in the directions. I apologize. Domain. All right. Domain we talked about last section. Of the 3 rules, 2 of which we know, which of those 3 rules can this possibly violate? Divide by 0. So if I set that equal to 0 and solve for x, how does this factor? -1? So what can't x equal? Good. So you want to keep those in the back of your head because we're going to need that information later on. All right, now we can talk about X-intercepts. So one more time. An X-intercept occurs when the function equals 0. But that instead of an f of x there, we'd have a 0. But a fraction equals 0 when the numerator equals 0. So you're only setting the numerator equal to 0. How does x squared plus 5x plus 6 factor? That's x squared plus 6x plus 5. X. Because we need them to multiply to 6 but add to 5. You did multiply to 5 but add to 6. Yeah. So what does that say about x? X equals Does anyone see a problem? Why? Makes the denominator 0. So the reason we have to find the domain first is to see what we're allowed to work with. We're not allowed to play with -3. It has cooties. So -3, even though it makes the numerator 0, it's not an X-intercept because it's not in the domain. So your only X-intercept is -2. Don't ruin it. Don't ruin it. Let's find the Y-intercept. How do you find the Y-intercept? Set x equal to 0. To find the Y-intercept, you put in 0 in for all of the x's. A lot of students just make the mistake of putting it only in the numerator. Oops, that should be a 0 there. You want to put it in for all of the x's. So if you put in 0 in for the numerator, you get +6. And in the denominator, we get -3. And so where is our Y-intercept? -2. So coincidentally, our X-intercept is at -2, as is our Y-intercept. I'm going to plot those 2 points for right now. Oh, that's +2, I'm sorry. So next up, we're going to find our asymptotes and holes, if any. So what I want you to do next is find your asymptotes and holes based on these guys there. Why I erase all this stuff. Let's talk about vertical asymptotes or holes. By finding the domain, previously we discovered that x cannot equal, what was it, -3 and +1? Right? -3, +1. So that's step one in finding vertical asymptotes or holes. Find where the denominator is 0. It's 0 at -3 or +1. So if we stuck in -3, numerator, what do we get? You should get 0. Make sure you put parentheses around the first -3, otherwise you're not going to square the negative. Because it's -3 quantity squared. Better? Okay. So since when you put in -3, you get 0, what happens at x equals -3? It's a hole. So holes mean more work. So how do we find the y-coordinate of the hole again? One more time? No. Remember, we factor and cancel. So how does the numerator factor? And the denominator was x, x minus 1, x plus 3. So notice they both have a common factor of x plus 3. So when it reduces, you have x plus 2 over x minus 1. And now what do we do? Plug in -3. Yeah. And that gives us positive 1/4 after we clean up. So our hole is at -3, positive 1/4. The nightmare is almost over, I promise. If we did, we would have gotten 0 divided by 0. And that's indeterminate. So that's why we had to reduce to get rid of that common factor. Alright, one more. Let's plug in 1. If we plug 1 into the numerator, 1 squared plus 5 times 1 plus 6, does that equal 0? No. So what happens at x equals 1? Vertical asymptote. Forgot to write hole before. So I'm going to put that on the graph. We have a vertical asymptote at positive 1. And we have a hole at -3, positive 1/4. So about right here. Boop. Hole. Look how happy that is. Like everyone in the class right now. What are we missing? Horizontal asymptote. What's the degree of the numerator? Yeah, they're both 2. So what's the ratio of leading coefficients? 1. So y equals 1 is your horizontal asymptote. I know, I'm so happy looks can't kill. I would have been dead by now. All right, that's all we have for the graph. Again, in this class, we don't have enough information to graph everything by hand. So if you want to, you can throw that into your calculator and hit graph. If you do that, make sure you put parentheses around the numerator and denominator. However, I'll just tell you the answer. It's going to look something like this, where it touches that hole, goes to the other side, goes through your X and Y-intercept, falls along the graph. And then you have another piece right over here. And I know I started with orange, I ended with red. I'll just fill it in. No one's got to know, except our studio audience. I should start every class with, math was